November 2025, Blue Origin launched New Glenn Flight 2 from Cape Canaveral, carrying NASA's ESCAPADE mission to Mars. This was New Glenn's second flight and its first NASA science mission. All 7B-E4 engines ignited cleanly, sending the rocket into a smooth ascent. Stage separation occurred on time, pushing the upper stage onto its Mars transfer path. The first stage then re-entered and landed successfully on an offshore barge, the first ever New Glenn booster recovery. The upper stage continued its burn and deployed NASA's twin ESCAPADE spacecraft exactly as planned. These probes won't land, they will cruise through deep space for about 2 years, reaching Mars in late 2027, where they'll enter orbit and begin studying the planet's magnetosphere and atmospheric loss. With this single mission, New Glenn proved its heavy lift performance, booster reuse capability, and NASA-rated reliability, a major milestone for Blue Origin. In October 2025, China launched its latest crewed spacecraft, Shenzhou 21, carrying 3 astronauts and, for the first time, 4 laboratory mice. The rocket lifted off from a desert launch site in the country's northwest and reached the Tiangong space station in just 3.5 hours, the fastest docking China has ever achieved. Among the crew was Wu Fei, only 32 years old, making him China's youngest astronaut ever sent into orbit. The mission will study how small mammals adapt to spaceflight, testing balance, stress, and biological changes in microgravity. Scientists hope the results will improve long-term human health in orbit and prepare for future missions to the Moon and Mars. SpaceX has made space history once more, completing a record-breaking mission. On November 17, 2025, SpaceX launched the Sentinel-6B Earth monitoring satellite from Vandenberg using a reused Falcon 9 booster. This flight marked SpaceX's 500th orbital mission using a reused rocket, a milestone no other launcher has reached. The first stage landed successfully on the drone ship, continuing the company's rapid launch tempo with multiple missions in the same week. Sentinel-6B is a joint effort between multiple space companies and organizations designed to measure sea level rise with extreme precision. It carries a high-accuracy radar altimeter and operates from a 1,336-kilometer orbit, replacing Sentinel-6A and extending global climate measurements for another decade. This mission highlights SpaceX's expanding 2025 cadence and its dominance in reusable rocketry. Jupiter produces the most powerful auroras in the solar system, measured at hundreds of times stronger than Earth's. These auroras are driven by volcanic activity on its moon Io. Io releases large amounts of sulfur and charged particles into space, which Jupiter's magnetic field traps and accelerates around the planet. This constant flow of plasma interacts with Jupiter's poles, creating intense ultraviolet and infrared auroras that are active at all times. Data from NASA's Juno spacecraft shows that Jupiter's auroras cover areas larger than Earth itself and release massive amounts of energy. They are permanent features of the planet and are directly linked to Io's continuous volcanic eruptions. In March 2025, a small Texas-based company made space history. Firefly Aerospace became the first commercial company to land a spacecraft on the Moon. No SpaceX, no NASA, just pure private engineering. Their lunar lander, Blue Ghost M1, touched down in the Mare Crisium region on March 2, 2025 after a flawless launch aboard a Falcon 9. Standing just 2 meters tall, it carried 10 NASA instruments designed to study lunar dust, radiation, and ancient soil chemistry. Unlike earlier private attempts that ended in crashes, Firefly's lander came to rest upright, fully operational, transmitting data and images from the surface. The mission proved that small companies can now reach the Moon and stay there. Blue Ghost M1's success officially opened a new era, commercial lunar exploration, led not by superpowers, but by innovators. The space race has officially shifted to the Moon, and the next major milestone is not another landing. It's long-term power. NASA is fast-tracking plans to deploy a 100-kilowatt nuclear reactor on the lunar surface by the early 2030s. This reactor is designed to power future lunar bases, mining operations, and nighttime missions when temperatures fall below -170 degrees Celsius. But the United States is not alone. China and Russia are jointly developing their own lunar fission reactor, intended for their planned International Lunar Research Station. Both sides understand the stakes. Whichever nation builds the first permanent, self-powered lunar base gains a long-term advantage in deep space exploration, off-world manufacturing, and access to lunar resources such as helium-3. NASA's reactor design is modular, heavily shielded, and engineered to operate for up to 10 years without refueling. China's system uses a compact fast-neutron design optimized for long-duration outposts. This new phase of the space race is no longer about flags. It is about securing energy, infrastructure, and influence on the moon. Scientists have just confirmed a new visitor from outside our solar system. A comet named 3I Atlas was discovered in July 2025, and it's only the third confirmed interstellar object humans have ever seen. Its path is hyperbolic, meaning it isn't captured by the sun. It's passing through once and leaving forever. Chemical scans show something strange. It has an extreme carbon dioxide to water ratio, far higher than any comet normally found in our system. That makes it one of the most chemically unusual objects ever detected. 3I Atlas is traveling tens of thousands of kilometers per hour, carrying the chemistry of another star's planetary system straight through our own. Once it swings past the sun, it will shoot back into deep interstellar space, never to return.